Hi, welcome to another video and episode about my riding robot discovery with the TXT controller from fischertechnik. Last time I experienced a problem with the data retaining capabilities, and I already replaced a battery, and that was the new battery, a standard CR2032. However, after replacing this, or better said, after putting this one in, the date was still a problem. So I decided to buy an entirely new battery, putting it in, and I have set the date straight. However, because this battery showed the correct voltage, I decided to measure it again. So let me check the battery once again, and this is exactly the voltage I expect from a new battery. So this battery that I just removed and replaced is just correct. Now, in order to check the current date which I have set, I am going to check the date again. Settings, date, and it says exactly the date I have set. However, what will happen when I set it down and switch it on again? Because not retaining the date with a very good battery could mean that the controller is in error. So let's check now again. I'm waiting a few seconds to be sure it hasn't kept it, and let's see again. Because the battery is really brand new, which is in it. So I'll have to wait until the controller has booted. And now there we are, back to the official graphical interface. There it goes. Settings again, date, and it is back to 2000. So this means that the controller probably has a problem, and it is not the battery. And if you have been watching my videos for some time, you may remember that I already replaced this controller. So this new one has a problem, and who knows how long that has been. So this is a downside to this controller, unfortunately. And I have two controllers, and I may need to check that there as well. So with this new knowledge, let's go further and see whatever happens. But I have to reset the date which is now not too problematic. This is the current date. So for now I set it, but this means that I have to set it every time. And I don't like that, of course. So back to current problem, motor synchronization. So it is time to take the test for motor synchronization into a slightly different direction. What I want to do is, apart from having this program, take out parts of the code and create a slightly different program. So I have to take out this. I will leave out camera action and then concentrate on motor. So as far as this goes, let's see if this is going to work. Test motor.py. Will this work? Yes, this will work. Great. Then leaving this out, I can leave out start camera online because I'm not going to need that. Time sleep, which is because of the camera, I leave out as well. I do have, however, to instantiate the motors. So let's do that. Yes. I don't have to use contacts, I don't have to use sonar, and the lamp I'm not quite sure of because it's not for wheels, but it has to do with the motor. That's something which is sure, because the output is for the motor, for a motor. So let me do that as well. Then what is next? I don't use contacts, so all these while elements I can leave out. What I need to leave in is, for example, this. And this is going to be wrong because there is no indent needed. Then what is needed is a sleeping time to allow everything for the motor to work. So is this it? Let's see if this really is it. What do I end with? What do I end with? Just another synchronization, and oh, that may be good as well, a stop online. So let's do that as well as another sleep. Not sure if it is strictly necessary, but let's just do it. So now I can quit for now this program. Write and quit. And let's go in here. Right, short program. So it's time to do some kind of a test, see if everything works as intended. So how do I run it? Run Python. See if this works. Yes, it works, but for a very short moment. So that is most likely due to the 700, which is located here. So I need to boost that. Let's say a replacement to not 100. I intended like twice as much, 1400. So I need this. Then 1400. Let's check again. Which is still very short. So the question is how short or how long should it be? That's the test. But for that I can use floor tests. So let's do that. So with a new floor test, let's see how this new kind of code works out. No objects to scan, just the motors, and that is a very short thing. So I have to check the code. And I changed the distance to 2000. See what that makes. That doesn't do a lot, I have to say. So if I say, for example, 10,000, what would that make? A factor of 5 more. A factor of 5 more, let's see. It is about distance. I don't think that this is correct. I can change speed, but then again it would only run so many pulses. So let me change that into 2000, 20,000 that is. Check again. And something that you have noticed, may have noticed, is that it really does not run in a straight line already. So let me put this back to where we start. Robot here at the beginning of the ruler, parallel to it. So let's see, because this is what it is about. Does it run a straight line? I run it a few times. And the question is, no, it does not. Or the answer is no, it does not run a straight line. So how to solve this problem. There is no sensor involved of any kind, just a motor. And it should really sync the motor. So is it a firmware? I don't know. Let me run it again. Does it run now in a straight line? What I can do is, of course, put the ruler here. What does it do? Just bits and pieces, but is it in a straight line or not? And even this is what I see, not in a straight line. The side is to the left, so that's a problem. Now, one of the things that is necessary for the synchronization of the motors to work is to make absolutely sure that the pulse counter is connected. And what I notice is first that I had to really make sure that the wires to one of the counters was connected correctly, but also when I click here on counter 2 it doesn't do anything. So let me run the motor. That works. Motor 2, that works. And here you see that they both work. So the counters do their job. And now I have more or less synchronized them, and they absolutely work. So the question is, why isn't my software working? And to that end I want to try to alter the code. And let me also stop the program. So what I want to do is actually get this data working, and to that end I go for a moment here, and this is the original documentation. It says here distance, so I need to find out how the distance is being set directly, and how can I put it in. Set distance, can I put it really on screen so I know that they're both the same. That's a good question. Can I do that? Or because this is just an argument, and it's not something you can do without it, but what I mean is, can I put this argument just as an argument for printing? That I have to find out. So let's go back to the code. What I can do I'm thinking of that right now, is that I say here, no, distance is, for instance, 5000, and that I say here distance, not here but here, I say no, distance, but then I have to find out what the input of the counter is, and I can't do that here. So this is one thing. So let me delete this one. Does this work? It should. Yes, it does. And for a very short time, for a very short distance, by the way. So let me make it about twice as long, twice as much. It does run a little bit longer. But anyway, it's time for some checkout if I can actually print out the pulse count. One of the things I have to do as well, as indicated by the documents, is to actually check if the motors have done what they should do, which is covering a certain distance. For that, there is the instruction finished, and then a function stop. Now I hope that I can do it with that, otherwise I'll have to do motor rest stop and motor link stop, but we'll see about this. How does this work out? If it does work out. Finished is not defined, because it has to do with motor rest finished. Nice one. And otherwise I'll have to put this in an if statement. And yes, I have to do exactly the same here. So this is a little bit different than the documents indicate, but okay for now. And this is odd because only the right side motor does do something at all. So what if I copy this and replace this by left, or to be precise, links here as well? What happens now? As it always takes some time for it to start. I don't see anything happening now. Nothing happens now. So that is a little bit weird. I will redo this by saying here if matter res finished. No, if not finished, oops, and this indicates finished is a boolean, and boolean means either 1 or 0, and of course this has to be an S, colon. Now I have to put an indent ready, so let's say 4 spaces, 4 spaces. Then I can delete this one and this one, and let's do here 4 spaces and here as well. See what difference this makes. Now they run both together and they stop, but at what distance is I have to assume that the 9000 really is covered. So if I change the distance to 18, they should run twice as long, but will they? That is a very good question. Not to my idea. So let's test this on the floor. So with the changed code, having now an if statement in it, let's see how it works out. This should be a straight line. And put in another way, 18,000 pulses counted, and they counted 4, but I don't see that happening. So let me do something else. I start the rower pro again. Let that walk and count pulses. That sounds like an excellent idea. And then see if things work as straight as possible. Alright, I just put them, oh that's a good one of course. How to put them to run at exactly the same time. I'm afraid I can't, but let's do something anyway. And that's what I mean. They have to stop. Ouch. Alright, next attempt. Ruler. Robot. Let's try something again. And that goes very fast. Oh right, it goes very fast because I put the speed on 8. Let me put the speed on let's say 2. If even possible. Alright, getting the robot again. Much slower this time. That is very slow. Now they have both speed 3 and they are both going counterclockwise and they are not counting pulses. They are counting pulses but they are not as you can see. This is not exactly what I intend to be a straight line. Not at all. So one says 20 to 26, but then again one started earlier than the other. But there are 4,000 pulses different. And one's running at the same speed in the same direction because it's running forward. You see that one is running quicker than the other, so that's a problem. And I don't know. And this is with Robot Pro, not even my own code, so I'm not quite sure how to solve this then. For now, that's it. Some problem to solve. Thank you for watching. Now it goes again, which is mysteriously that it does something like this. If you like my videos, please subscribe to my channel, see my Instagram and Twitter, and if you like my videos, please consider to allow advertisements to run, and or consider to use PayPal for our website and blog support. To be